Hello everyone, today I'm going to talk about creating project on Keil. So for the first lab, we are going to build a module for updating the clock for Cortex-M0 processor. To do that, we're going to make a project in Keil. So let's start. So first, from the project menu, we have to select new project, and then we will select the we'll select our project folder. So lab 0 project, and now the name of our project, which is lab 0. So we're going to select the KL2X processors family, and from here we can see that we're going to use this one. Okay. And now, since we're going to use the startup code for the processor, we have to include it into the project, and we're also going to need the core codes for the processor. Okay, so then we select OK. Okay, now we're left with an empty project. So from this group, we're going to add our source code. So we need to add a new item to the group. So we can name it whatever you want, but I prefer to put main.c as our main C code. Okay, so now we can see that we have it here. So from here we need to include the MKL25Z 4.h header file, which is basically the register addresses to the for the MKL25Z4 processor. And now we can write our main C code. So void main. Sorry, we need to use int main void. Okay, to make sure that we've done everything correctly, we need to compile the file. Okay. So the warning is basically the last line of the file ends without a new line. So just add a new line here and then compile it again. Okay. So we have 0 errors and 0 warnings. Now let's update the clock for the let's set the clock for the processor. So there is a built-in function system core. So system core clock update. And for the autocomplete in Keil, you can press Ctrl and space, which I did here. So basically, when you press Ctrl and space at the same time, you will have some options. So, okay, system core clock update, which is updates for. So, okay, now let's. So to see where does this file has been declared, you can go to system MKL25Z4 startup code, and at the end of the file you can see this function, system core clock update. So let's run the code, compile the code. Okay, so no 0 errors and 0 warnings. And basically, if you don't call this function, what would happen is that the clock would not be locked on the correct frequency, and you will face like many other problems in the in building your file. I mean, in running your file on the board. So you may have 0 warnings or 0 errors in the Keil, but when you implement the code and when you want to run the code on the processor, you will see either no correct output, or I don't know, like a malfunction on in the processor. So let's let's download the hex file into our processor. So we need to, basically, because this is the first time that I'm connecting a board to this project, we need to define the debugger. So which is PE my macro debugger, and then okay, and then we need to load the file to the processor. For the first time, this window will pop up. We need to choose our device, which is MKL25Z 128M4, and since we'll be using OpenSDA embedded tower debug in our project, we need to select this one, and you can see that it found my device, which is connected to the USB one, and then we'll say connect, and yes. Okay, so now the board is programmed with our program. So we can go into debug mode to see our processor working. So basically we want to see 48 megahertz as our core clock value. So we can see, okay, so we can add in our view, we can add a watch window, and then we can call system clock, which is actually, so you can see, you can put it in hex or int. You can use the int or hex value as I showed you, but the thing is that it's now only 42 megahertz. Let's update the clock, and it's still locked on the 42 megahertz. So the really important thing in this startup code is that you need to basically select the correct configuration for the clock. So to do that, you can go to, so now let me explain the problem. So we saw that the clock is now locked into 42 megahertz, but we need 48 megahertz for some reasons, which you will face later in your design. So basically, it's good to select 48 megahertz as our core clock. So there is in our system startup code, in the C file, not in the assembly, in C file, there is a definition for clock setup. So you need to set that to 1, and everything is explained in this comments. So you can see, if you select 1, multipurpose clock generator in PLL engage external mode, reference clock source for MCG module is an external crystal 8 megahertz. So basically what it does is going to select the PLL basically it's going to select the MCG, the PLL output for MCG, and then it's going to select the PEE mode for the for the reference clock. And since our crystal oscillator on the board is 8 megahertz, it will generate 48 megahertz as our core clock and 24 megahertz as our bus clock. Okay, so now let's build the project, and now now we expect to see 48 megahertz as our core clock. So let's program the board again, and now let's go to the debug mode. Connect. Okay, now you can see that it's now set to, the system core clock is set to 48 megahertz. Now let's run the code. Okay. Okay, so this was for lab 1, which is basically nothing. It's just updating the core clock. Okay, thank you.